Our lesson on 1.4 is titled Rewriting Equations and Formulas, and really the goal of lesson 1.4 is to isolate a variable, which is kind of like solving, but a little different. So we're going to look at the first two examples. It says solve each equation for the indicated variable. So 7x minus 3y equals 8, and they want us to solve for y. Well, the first thing I want you to do is put a box around the y. It's kind of like locking it in place. So now your job is to figure out how to get the y by itself. And the first thing I would do is I would take whatever is being added or subtracted to the y and move it over. Well, the 7x is positive, so to move it to the other side, we're going to have to do the opposite, which is subtract 7x. Now when you subtract 7x from both sides of the equation, you're still left with a negative 3y equals, and you can either write 8 minus 7x, because they're not like terms, you can't combine them, or I'm going to go ahead and write the x first, just because a practical use for this technique is to solve for something in slope-intercept form, which means we want the x to come before the constant. So again, we're still trying to get this this y by itself. So right now y is being multiplied by negative 3, so to undo that we're going to divide both sides by negative 3, and what I want you to think about is dividing everybody individually by negative 3. So your final answer is y equals, this becomes a positive 7/3 x minus 8/3. Okay, letter B says L equals PRT, and they want you to solve for T. Well, normally I'd look for what's being added or subtracted to the variable to begin. Nothing is being added or subtracted to it. So all I have to think about is how to move the P and the R to the other side. Well, they're attached to the T by multiplication, so the opposite of multiplication would be to divide by P and R. And as long as I do it to both sides, I'm good. And I think we're done. T equals whatever the length is divided by PR. Okay, moving on to our next example. They want us to solve for x. So I'm going to go ahead and put a box around the x and think about how I'm going to get that isolated. So first, I notice that this negative 9y is attached through subtraction. I'm going to go ahead and add it to the other side. And when I do that, I get 11x equals, I could say negative 4 plus 9y, but I'm going to flip that around just because I like the variable to come first. 9y minus 4. And then again, remember we're trying to get the x by itself. So in order to do that, I'm going to go ahead and divide both sides by 11. I'm going to divide every single term individually by the 11. And I'm going to end up with x equals 9/11ths y minus 4/11ths. Okay, letter D is kind of weird. If you notice here, they want us to solve for y, but bad news, we've actually got two y's in the problem. So I'm going to have to think of a way to rewrite this so that there's just one y in the problem, and the technique we're going to use here is a factoring out technique. So I'm going to pull the y actually out of this entire expression right here. And when I factor out a y, it's like the opposite of distributing. I'm left with an x minus 1, because when I take out the y here, I'm still left with a minus 1, equals 10. Well, now this is not too hard to solve for, because the only thing that's attached to the y is the multiplication problem of the x minus 1. So we're going to go ahead and get rid of that by dividing by the quantity x minus 1 on both sides. That'll cancel the x minus 1's, leaving us with y equals 10 divided by x minus 1. Okay, so the lesson there is if you have more than one of your variables show up, you need to group them together and then factor out that variable so there's just one of them in the problem as opposed to several. Okay, let's talk about the next example. Find the value of y for the given values of x. So I'm going to go ahead and use the technique of us solving for y first, and then I'm going to substitute in the value that they provided for us. So let's go ahead and get this y by itself. So first thing I'm going to do is subtract the 3 over. And when I do that, I get 2y equals x minus 3. And then divide both sides by 2. And again, I'm going to divide everybody individually by a 2. It's not horribly important that you write it in this way, but I do like it for future problems. Alright, so we're not quite done. They actually have us do one more thing. It says, once you find this, figure out what the value for y is when x equals -1. That's what they told me at the beginning of the problem. So if I'm going to go ahead, whoops, and plug in x equals -1, and when I do that, and you can either use your calculator or your brain, I think I end up with y equals -2. Alright, let's try letter B. xy minus y equals -4, and they want us to later substitute in x equals -4. So again, I want you to solve for y, but we have that same problem we had a couple problems ago where there's too many y's in the problem. So I'm going to go ahead and factor out that common y. And now it's really easy to solve for it. We're going to go ahead and divide by the x minus 1 on both sides of the equation. So they cancel out, and you get y equals -4 divided by the quantity x minus 1. Well, again, we're not quite done yet. They want us to figure out the value of y when x equals -4. So when I go ahead and substitute that in for the x, I end up with 4/5 positive. Okay, very nice. Moving on. You're organizing a benefit concert and you plan on having 2 types of tickets, adult and children's tickets. Write an equation with more than one variable that represents the revenue from the concert. So let's think about this. Revenue means how much money you're going to bring in. So I'm going to say the revenue is going to have to equal, let's say the adult tickets. Now I actually need 2 variables here because not only do I have to think about how much an adult ticket costs, but I also have to think about how many adult tickets I'm going to sell. So I'm going to say AX. And then same thing for children's tickets. Not only do I have to think about how much a children's ticket costs, but how many of them I'm going to sell. So it probably would be important if we go ahead and define these variables. So this guy here is revenue, which is how much money we bring in. I'm going to call A the price of an adult ticket. And I'm going to call X the number of adult tickets. Whoops, there we go. And I'm going to call C the price of a child's ticket. And I'm going to call Y the number of children's tickets. And it doesn't matter what variables you use or what you have them represent, as long as they come out to the same representation as what I just showed you. You can use smiley faces and ponies for all I care. Let's move on to the next problem. For the concert in example 3, your goal is to sell $25,000 in tickets, and you plan to charge $25.25 per adult, and you expect to sell 800 adult tickets. But we're not really sure how many children's tickets we're going to sell. So we're going to have to figure out how much to charge depending on what we really end up thinking is going to happen later on. So the first thing I want to do is when I look at my equation, R equals AX plus CY, and the whole thing that I don't know is how much I'm going to charge for each children's ticket. Well, remember, that was the variable C. So what I would like you to do now is isolate this equation for the C. So get C by itself. So first thing I'm going to have you do is subtract this AX over to the other side. So I end up with R minus AX equals CY. Now I'm going to kind of go against what I said earlier. Instead of dividing everybody by a C, I'm just going to have you draw a really big fraction bar like this. Because I'm going to do a lot of calculations, and because, you know, things aren't really working out the way I wanted to, I'm just going to leave it kind of ugly like that. Now, instead of using all my variables, R minus AX over C, I'm going to plug in anything that I can figure out from the information they gave me. For instance, R, the revenue, is $25,000. Oops, look what I did. Back up, this is Abruzzo. Back up one step. I solved the wrong variable. Goodness gracious. I was supposed to solve for C. So I should have divided both sides by Y. Alright, hopefully you caught my mistake there. So anyways, let's back up. C C equals revenue is $25,000. A was the amount we're going to charge for an adult, which was $25.25. And then X was the number of adult tickets, which was 800. And then we're going to divide all of that by the number of children's tickets. Now, unfortunately, that's going to kind of change. So I'm going to want you to just put a Y there for now. All right, we need to get our calculators out. And we need to, oops, I lost my calculator. We need to figure out 25,000 minus 2525 times 800. So, oops. 25,000 minus 2525 times 800. Our numerator becomes 4,800. So let's get back to our presentation. And now it's going to be really, really easy. These numbers they set up for us here are just going to be our ever-changing y's. So if I was to plug in a 200 right here for the y, 4,800 divided by 200, I end up with $24. But if I plug in a 300, 4,800 divided by 300, I think I end up with $16. And if I plug in a 400, 4,800 divided by 400, I end up with a $12. So as we kind of would have thought, the more children's tickets you plan on selling, the less money you have to charge for them, and that's kind of how economics works, at least for this problem. All right, moving along. Rewriting some common formulas. There's a lot of common formulas that you're going to see pop up in this homework assignment, and a very common one is perimeter of a rectangle. The perimeter of a rectangle is twice the length plus twice the width. Well, I want you to take this formula and I want you to solve it for W. So I want to put a box around the W. And if we solve for that, we're going to first subtract the 2L over. So perimeter minus twice the length equals twice the width. And again, we're going to divide everybody by 2. Now, you can either write it with a big fraction bar like that and say that W equals the quantity P minus 2L divided by 2. Or if you separated those and just divided both of the parts of the numerator by 2, you'd have P over 2, and then 2L over 2 just becomes 1L. So either one of these answers are great. Whichever one appeals to you, go ahead and write it down. Okay. On the back of your notes, just some more of the same sorts of problems. Let's do some more practice with these. They want you to first solve for y, and then they want you to substitute the x into the equation. So if I'm first solving for y, I'm going to put a little box around the y. Let's go ahead and subtract the 3x over, so you have 2y equals negative 3x plus 1. And then let's divide everybody by a 2. Now I'm going to kind of cheat this time. I'm not going to divide everybody individually. I'm just going to end up with negative 3x plus 1 in the numerator, and then all of that divided by 2 in the denominator. And we're not done. Remember, they gave us a value for x to plug in at the end. So we're going to go ahead and say negative 3 times the 5 plus 1, and then cut that by 2. So let's see, negative 15 plus 1 is negative 14, cut in half should give us a negative 7. Now there are problems on your homework that are just like that, and you need to show all your work. So number 2, they want us to first solve for y. Now you should notice that there's 2 y's in the problem. So the technique we used for this was to factor out that common term of y, and that left us this time with x minus 2. And then to get y by itself, we're going to have to divide by the quantity x minus 2 in order to cancel those out. So we have y equals 12 over x minus 2. And take it one step further, they told you they want you to substitute in x equals 3. So 12 divided by 3 minus 2, which gives us a 12. No, it doesn't. Oh yeah, it does. We're good. All right, moving along. Let's talk about number 3. 1/2 x plus y equals 1. We need to solve for y. That's really easy to solve for. I'm just going to subtract the 1/2 x over. And that's kind of almost done. Last thing we need to do is plug in x equals -6. So we have -1/2. X is -6. And then add the 1. So let's see. That becomes a +3 plus 1, which is a 4. Moving along. A common formula in math is distance equals rate times time. And if we're going to solve for t, that's actually really easy. Rate times time, so the opposite of multiplying is just to go ahead and divide by the rate. So your final answer is time equals distance divided by rate. Okay, similarly on number 5, interest is principal times rate times time. So if I want to solve for principal, I can go ahead and divide by both the r and the t. So I end up with principal equals my interest divided by rate and time. Okay, next one looks a little more complicated. Number 6, area is the height divided by 2 times base 1 plus base 2. That's the area of a trapezoid formula. If I want to solve for h, the first thing I'm going to do, it's actually kind of not the only option, but what I'm going to do is I'm going to multiply both sides of the equation by 2. And the reason I'm going to do that is because I want these 2's to cancel out. So I end up with 2a equals h times the kind of quantity b1 plus b2. And then if I want to solve for h, remember, I can go ahead and just divide by b1 plus b2. Kind of like those problems where we factor out the common term. Kind of look the same way. I think we're done. So my height is equal to twice the area divided by b1 plus b2. Okay, number 7, s equals pi times big R plus little r. So if I'm trying to solve for big R, I need to get rid of that pi first because that's kind of hanging everything up. So if I go ahead and divide by pi, that ends up as being s over pi equals r plus little r. And remember, we're trying to solve for big R. So I'm going to go ahead and just subtract the little r over. And it looks kind of goofy, but we're done. I'm going to flip this around. Big R equals s over pi and then minus r. Okay, this next problem has a couple steps. Make sure you actually solve all the steps on the homework assignment because every part would be worth a point if this was a test question. So it says solve for the indicated variable, then evaluate with the given value. So the perimeter for a square is 4 times the sides, and the first thing I want you to do is take this equation and solve for s. So if I was to solve for s, it's actually really easy. You just divide by 4. So we're going to write down s equals perimeter divided by 4. And then evaluate, find s when p is 44. So s equals, let's substitute in the 44, and we get an 11. And that's the length of the side, so if I want to label it, I need to go back and look at the rest of my problem. These were measured in centimeters. Very nice. Okay, the next problem is area of a rectangle is length times width. The first thing I want you to do is solve for length. So we're going to go ahead and do that by dividing by w on both sides. And we get length equals whatever your area is divided by your width. And it says find the length when the area is 2 feet squared and the width is 8 feet. This comes out to a decimal or a fraction. I don't care which one you write down. I'm going to go ahead and write 1/4, and then if I look at my dimensions, they're in feet. So it's 1/4 of a foot. Could easily convert that to inches instead of 1/4 of a foot to where a decimal would work fine for this problem. And I think that concludes our lesson on 1.4.